Hello, groundwater peers. This is Aaron from BGR. Today I want to show you a novel tool for the estimation of hydraulic parameters for any type of hydraulic groundwater calculation that you want to do. So, for example, you may plug in the hydraulic parameters that you may estimate with this new tool into your numerical groundwater flow model. All right, so this is the little tool. It's just a little Windows-based GUI. And what you can do with this is you can estimate, for example, a value for effective porosity by means of a single input of hydraulic conductivity. So if you know about your hydraulic conductivity, but you don't know any effective porosity, then you may use this tool to estimate a value. Let's just quickly do this. Let's say we have a hydraulic conductivity of IE minus 4, and we just hit the calculation button, and then we see we get a range of parameters that were estimated based on this value. And at the very bottom of it, you can see such a hydraulic conductivity corresponds to an effective porosity of 0.283. The other values you see are what we call virtual grain size distribution. These are the characteristic grain diameters D10, D20, D50, and D60. Right. You may also obtain a hydraulic conductivity and an effective porosity by means of a single input value of D10 or D20 if you want to. So let's just plug in a value for D10, 3, something like this. Ooh. Okay, you see we get a warning here because I'm out of model bounds. I should have chosen a different value. All right, let's say we do this. Okay, then we're in model bounds. All right, so if you have a knowledge about a D10 value for your hydraulic calculations and you want to estimate a hydraulic conductivity and an effective porosity, for example, then you may use this setup to estimate those two values. All right, so let's talk about the tool in general a little bit. So up here on top, you can choose a parameterization. These are Cosini-Kármán based, Bayer-Schweiger based, and Hazen based parameterizations. Hazen and Bayer-Schweiger are two empirical models that relate a hydraulic conductivity to a characteristic grain size. Cosini-Kármán is a physically based model that relates a hydraulic conductivity to an effective porosity and to a characteristic mean grain size. So both of them, of course, you have to include the fluid properties and gravitational acceleration and so on. Okay, so if you're unsure about the parameterization, then I would recommend to use the Cosini-Kármán based parameterization because it's not restricted to any region on this Earth, and it also is the only physically based model. Okay, down here you get an area where you can choose which parameter your calculation is based on, which input parameter it is based on, and you can see by now at the current stage of this tool you can choose hydraulic conductivity, D10 or D20, and to obtain all the other parameters from such a value. Let's just do it for the fun of it for the last input value of D20, and there you can see you can obtain hydraulic conductivity, D10, D50, D60, and effective porosity by a single input of D20. All right, then you have certain buttons down here. You can, for example, let me do this quickly. You can, for example, plot a sieve curve, a virtual sieve curve of your setup. I just have to pen it in here. Looks something like this. You may use it to pen left and right in the sieve curve. You may also zoom if you want. And the only thing you can see here is the estimated values for D10, D20, D50, and D60 drawn over cumulative sum or volume fraction, which is a classical sieve curve. All right, you may use this figure, of course, for your presentation purpose. You can just save it and put it in your whatever presentation. All right. Then we have also an About button. This About button, basically, it refers to the paper, which you can see in the background, where everything is described in detail. But yeah, there's some more information here for the user. All right. However, I just quickly want to get into the method behind this tool. So what we did is we analyzed around about 1,000 sieve curves, which were globally distributed. So from all around the world, we assembled a data set with sieve curves, and we tried to find interparameter correlations, and we found some correlations that enabled us to derive a mathematical model which may calculate all these things based on a single input. And yeah, for further details, I will refer to the paper at this point because it would be tedious to explain it here. It would be boring for you probably, and I would have to find the words. All right, so I quickly want to show you now, last, how to download the tool. And let me just quickly pen this here. You can download it on my GitHub repository. So it's this one. You can also find a link in the subscription of the video, and you can also find the link in the paper. And in this repository, you may download the executable that you've just seen, and you also have to download a folder that's called source code zip. I already did this, and I will pen it in. So if you did that, then you have these two folders downloaded. And what you have to do is you have to unzip this folder. Then it looks like this. And you have to copy the folder hyperx dependencies into the location of your executable. Because in this folder there are some image files that you refer to. And then you can just double click on the executable and it fires up. And you can use it whenever. If you want to copy it somewhere else, to a different location, to a different laptop or whatever, you just have to copy the executable and this folder. And you can distribute it wherever you want and use it wherever you want. It is a standalone executable. Right. I think that's it. If you have any questions, please contact me. If you have any suggestions, please also contact me because we are currently working on this tool and we are redeveloping it. At the moment, we're working on estimating more parameters based on a single input value, of course. All right, so for everything else, please refer to our paper. And yeah, thanks a lot for listening, and I hope you find the tool helpful. Of course, it's for the community, and everyone who wants should use it and should use it for free, and so on and so on, and should modify it if he wants to. That's why it's open source. All right, so thanks a lot for listening, and well, bye bye.